Hi everyone, this is our first lesson in a much larger unit about force and collisions and things like that. So our first lesson is about force, and what I want you to understand in the learning target is to explain force and the relationship between force, mass, and acceleration using mathematical thinking. So just a reminder, this is a video with guided notes. So please find a good spot in the classroom or wherever you are so you can focus on the video. Make sure you have a copy of the guided notes. There's a digital version as well as a hard copy in the classroom. And the use of headphones is suggested, especially when everyone is maybe on the same lesson. It can get kind of noisy in the classroom, so headphones are recommended. So if you need to pause the video while you go get your guided notes, now's a good time to do that. Okay. So what is a force? Uh, in common terms or in our society, the term force can be used in many different ways, especially in Star Wars. And I'm wearing my Star Wars shirt today, which says, May the force be with you. But it has the force equation. Anyways, but really for us, a force is a push or a pull. That's it. That's a simple definition. Okay, force is a vector quantity. It has a direction. So just like displacement, velocity, acceleration, force is a vector quantity. So watch out for the directions. Okay, just a reminder, right, up, north, east, those are all positive values. And then left, down, south, west are negative values. And so this is commonly how we might depict a force. We might talk about a person pushing an object. And you'll see there are many questions, even in textbooks, about a person pushing a box. And that's just a little bit of a tangent here, but that just makes the object very simple. We're trying to just focus on understanding force, and so we try to choose like a very simple object. So we'll often talk about like a person pushing a box, okay? And this is how we might draw that, that example. All right, and then there's many types of forces. There's magnetism, there's gravity, there's friction. And so you'll see that force is really determined by an object's acceleration and its mass. And that's exactly what is in our next slide here. So force is mass times acceleration. That is a simple equation that you'll be using quite often during this lesson. So Isaac Newton's second law says that force is mass times acceleration, or sometimes we just simply write that as F equals ma. And the SI units for force are newtons. So Isaac Newton was kind of a big deal, and he had the units for force named after him because he came up with these laws. And just a reminder, so newtons is the unit for force, but we're going to also use mass and acceleration a lot in this lesson. So the units for mass are often kilograms, and then the units for acceleration are meters per second squared. And so you can kind of see in this cartoon here that the acceleration of the car comes down to some force applied, whether that force is like in the engine. All right, kind of a side note here, but Isaac Newton developed three laws of motion, but the second law is the most famous, which is F equals ma. Some engineers even joke that F equals ma is all you need to be an engineer. It's such an important equation, it might be the most important equation in engineering. It's essential to build all the amazing structures in our world. I have a couple of pictures here. The one on the left is the Burj Khalifa. It is the tallest building in the world. It's more than twice as big as the Empire State Building. And then another picture is a dam. I mean, you have to think about how much pressure and how much force that water is pushing against that structure, but that structure is able to withstand that force. So if you can understand the idea of force, then you can build some amazing things. All right, so here's the basic relationship. So as force increases, acceleration also increases. So imagine as you push harder on an object, you're applying more force, then it will speed up faster. And so that's what this graph over here is showing with the green line. It's a pretty simple graph. It just shows that as force goes up, so does acceleration. And then the other bullet point here is that as mass increases, acceleration decreases. So heavier objects are slow to speed up. Imagine pushing something really, really heavy, and at first it might take a lot of force to get it to just budge a little bit. So there's an inverse relationship between acceleration and mass. And so that's what this little graph is showing here. So you can imagine that if the mass is really low, then the acceleration is going to be really high. And so that's kind of what this part of the graph is showing. Now, on the other hand, if you apply the same force to a much heavier object, something that has way more mass, then the acceleration is going to be very low. All right, so it's inversely related. And then the final thing I just want to mention in this video is some common terms that you'll hear. So push and pull, obviously, those are indicators of something being moved. But other terms that you'll hear related to force are apply. Somebody is applying a force, or a force was applied. You might hear exert. A force was exerted on an object. Or how much force do you need to exert? Da, 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 da. And then net force. Net force we'll talk more about in the next lesson, but net force is just the total amount of force acting on an object. And then balanced and unbalanced. Again, we'll talk more about that next lesson, but you might see it in some places now, so I'll introduce it now. Balanced forces are ones that are, maybe equal and opposite. And then unbalanced means that there's a stronger force on one side of an object compared to the other side, and that will lead to some acceleration in the object.